Alright, today we're going to look at area between a curve and a line. So this makes use of the topic of integration. Alright, so I'm just going to go to the next slide. Okay, so from here, right, you can actually see, okay, let me just call the pencil, that the area that we wanted is actually the one in pink here. So normally how you will go about it is that you can actually look at it like there is this part here that is bounded. Alright, I hope you can see this. And if you actually look at the fact that it's bounded by the x-axis, which is what we have been usually doing, right? It's actually going to be this entire area when you integrate, all right? Now, the first thing to do, of course, is to find out the coordinates of A and B. So to find the coordinates of A and B is actually quite simple. You have this equation and this equation. So all you have to do is just to set it together and you'll be able to solve it. All right, so you can have x squared minus 5x plus 4 equals to 0. And you'll be able to get it that it will be between 1 and 4. So in other words, when you integrate between 1 and 4, you're actually getting the entire blue area. But you actually need only the pink area, right? So what you will need to do is, if you look very carefully, right, this bottom part here is like a rectangle, all right? So I'm going to use a different color. So this part here, right, is a rectangle. So if you actually want to find the colored pink area, which is down here, you just have to take the original integrated one, and then you just have to minus off the rectangle. So this is how you go about it. So you can actually integrate between 1 to 4, and this is going to be your curve that you're going to use, which is 4 plus 5x minus x squared dx. So you're getting the entire blue one, all right? So this will give me 4x plus 5x squared over 2 minus x cubed over 3. So you're integrating between 4 and 1, right? So in this case here, you just have to put in the numbers. Okay, replacing the two values that you have. Okay, and when you key into the calculator, the whole thing, you'll be able to get it as 28.5 square units. All right, so that is the entire blue one. But you wanted only the shaded part at the top, right? So you have to see that the rectangle itself, right? Okay, sorry. This part here is actually 3 units, and this part here is actually 8 units. So the rectangle itself, the area is 3 by 8, which will give me 24. So the shaded area will be just 28.5 minus 24, and you get it as 4.5 square units. So this is a usual way that most people will do because it's easy to see that, you can just minus off. But can be a bit troublesome. So another method is what I call the push method. So the push method, right, actually makes use of the fact that it's as if you have pushed the x-axis either upwards or downwards. So in this case here, I'm actually trying to sort of like push it. So in other words, right, you can see the fact that to make my x-axis go up, it's as if my curve, this curve, has gone down by negative 8 units. Why negative 8 is because you have y equals to 8 here. So in other words, it will look like this. All right, it has been pushed down by 8 units, okay, and now it will be resting very nicely on the x-axis. Okay, so this method, you don't have to minus off the rectangle, but you do have to change this one here because you push down by 8 units. So you're going to integrate. Now, the parts that you got earlier on, right? Okay, the fact that you got 1 and 4 for the x doesn't change. So you still have 1 and 4 down here. So what you're going to do is that now, right, from the original equation, y equals to 4 plus 5x minus x squared, you are going to do a minus 8, means you push the curve down by 8 units. So you're going to have it as negative x squared plus 5x minus 4. So this is the one that you're going to use to integrate, all right? So you're going to integrate from 1 to 4, negative x squared plus 5x minus 4 dx. And then what you're going to get would be, you can get negative x cubed over 3 plus 5x squared over 2 minus 4x. Now, earlier on, you got it differently, right? So now you have to just be mindful that this is the new one that you have, okay? So 4 and what? And you also put the values in accordingly. But the good thing is that we don't have to do any subtracting after that. This is already what you have. So this push method is pretty easy, right? Because all you have to do is just to push it down, put in the values, and voila, you have the answers straight away. Alright, so you can check the calculation with your calculator, of course. So this pushing method is letting the colored part or the shaded part rest on the axis that you want. So since it's going to rest on the x-axis, so of course I'm going to do a dx. If it's going to rest on the y-axis, then I'll do a dy. Alright, so no need to minus anything. What you see is what you get. So that's the push method. Alright. Okay. Now, what if it's not so obvious? Okay, like this case here, you notice that this one here, we have a slanted line. So you have a normal straight line graph. Okay, so in the form of y equals mx plus c. So this is what you have. So let's go with the very first method first. Okay, so the first method, remember, we can actually think of it like this. Okay, so let's just find the intercepts first. All right, so we can have, so when y is 9 minus x squared, we equate it to 7 minus x, so we'll have x squared minus x, you bring this one over, minus 2, right? So you'll be able to have 1 and 2. So one of it will be plus, one is minus, so x can be negative 1 or x can be 2. So this will be negative 1 and this will be 2. Alright, so if you were to do the normal way and you integrate, this will be the blue colored part that you're going to get. Alright, and what you will notice is that you can have trapezium, which is down here, right? So you can kind of minus away the trapezium later on. Okay, so the blue color part, right, is the entire curve. So you can see it's bounded by this one here and this line here, right? So actually the blue color part is this whole thing here. So you can find that and minus away the trapezium. Okay, so how we can do this is very simple. So we're going to integrate between negative 1 and 2 using 9 minus x squared, right? And later on, we'll minus away the trapezium. But the problem is that to minus off the trapezium, right, we do not know the height here, right? So what we can do is we can find the y value for this coordinate. So when x is negative 1, y is 7 minus negative 1, we'll get this as 8. So this coordinate here is negative 1, 8. So here it's going to be 8 units. Now doing the same for the other x value, so y will be 7 minus 2, you get it as 5. So in other words, this coordinate here will be 2, 5, and this one will be 5 units. Then of course, this part here from negative 1 to 2 is 3 units. So for my trapezium, I'm just going to draw it down here, 8, 5, and 3. So trapezium is half a plus b times height, right? Okay, the perpendicular height, which is down here. So this is what we're going to have. So if you do your integration, this is what you're going to get. 9x minus x cubed over 3, 2 and negative 1. You calculate the trapezium, you should be able to get it as 19.5. And for this one here, when you put it in, you'll be able to get it as 9 times 2 minus 2 cubed over 3 minus 9 times negative 1 minus negative 1 cubed over 3. And later on, you'll minus with that. Okay, so this part here will give you 24 then you minus 19.5, and you will also get it as 4.5. Very strange, huh? A lot of 4.5 areas here. Okay, so that's the usual way where you need to do your integration between negative 1 and 2. So you're going to get this part here. Okay, this part here was actually the entire curve. Then you have to minus away the trapezium, and that will actually give you the shaded part that you wanted. Alright, so you can get it done this way. Of course, you also can do the push method, meaning that you are going to assume that now it's going to rest on the x-axis. So you can do it this way. Okay, so x-axis is here. And instead of trapezium, you'll be able to get it as a triangle. Alright, so if you remember, we got this coordinate here as negative 1, 8, and this coordinate here was 2 and 5, right? So for it to rest very nicely on the x-axis, you will actually be pushing by 5 units. So you're pushing down by 5 units. So what we're going to have is that y equals to 9 minus x squared minus 5. So we will have negative x squared plus 4. So when you integrate between negative 1 and 2, right, you are going to be able to get something like this. Okay, the area under the curve. Right? Of course, this was the line. So integrating from negative 1 to 2, you'll be able to use negative x squared plus 4 dx. So you'll be able to get it as negative x cubed over 3 plus 4x, 2 and negative 1. So putting it back in, you'll be able to get it as negative 2 cubed over 3 plus 4 minus negative 1 cubed over 3 plus 4 times negative 1. Okay, so this entire area, when you calculate, it should give you 9 square units. Now, for the triangle, this is 8, right? The whole thing was 8, this is 5. So 8 minus 5, right? This would have been 3. So for your triangle area, it would have been 3 here and 3 here. So area of the triangle would have been half times base times height, which will give you 4.5. So again, the shaded area would have been 9 minus 4.5, and you also get it as 4.5 square units. Alright, so you had the original method where you minus away the trapezium, or the pushing method where you actually minus off a triangle. So there is actually a third method, which I call the sandwich method. Now the sandwich method, right, will take the difference between the bounded equations, like for instance, the curve and the line, right? So there's always going to be one curve and one line for your syllabus. So one will be a line, one will be a curve, but it depends on whether the curve is below or above, all right? So sandwich method will be here. It means that I'm going to find this sandwich area straight away. So I will make use of the original two curves here. Okay, so how this works, right, is very simple. Look and see which was the bounded at the top one. Okay, I'm going to use a different color here. So maybe I will use green. Okay, so this green part here is the top. So top dot reigns, right? So the top will always come first. And the line here, okay, so this was a line that we used, right? The blue one here. So this one is considered as the bottom of the sandwich, right? So the top will come first, the bottom will come later. We will have to take the difference between the two, okay? So what do I mean? This time around, right, you basically don't have to bother about finding the y values, all right? But you will definitely need two equations. Okay, anyway, let me just go through this first. So earlier on, already knew that this is between negative 1 and 2, right? So what we're going to do is that we are going to do between negative 1 and 2, but we are going to take, first of all, the difference between the two curves. Top dot, the top one, comes first, minus away. Okay, so this is a minus, minus the bottom one. Okay, so that's the bottom of the sandwich, which is this equation here. So we have 7 minus x dx. Okay, so top minus bottom. I didn't say curve minus line because actually sometimes it can be the other way around. So when you continue on, so you do like per normal. So you will notice that 9 minus 7 will give you 2, right? Okay, so this is what you're going to have. You're going to integrate between negative 1 and 2. 9 minus 7 is going to be 2. Negative will be positive. And minus x squared is as usual. Okay, so we're going to integrate this. So what we're going to have is 2x plus x squared over 2 minus x cubed over 3, 2 and negative 1. Alright, so putting in the values. Okay, so I should have written out area. Okay, sorry about that. So we have 2 times 2 plus 2 squared over 2 minus 2 cubed over 3 minus away 2 times negative 1 plus negative 1 squared over 2 minus negative 1 cubed over 3, and straight away you'll be able to get it as 4.5 square units. No need to minus anything, no need to worry about what kind of shape, whether it's trapezium or triangle, whatever. It's just a sandwich. All right, so the sandwich method is very useful because you don't have to worry about minusing off. So what is the problem with the sandwich method? You must have two equations, all right? Both the line and the curve. If you don't have it, you have to find out, all right? Which we're going to do later on. So in a nutshell, this is the summary for the sandwich method. There'll be two equations, one linear, okay, linear, so it can be this way, it can be this way, it can be this way, all right? And you have a curve, all right? So whatever the curve is, like it can be this way, or maybe part of it, whatever, all right? So you will have a linear and a non-linear. Take note of which one is the upper one, naming as 1, equation 1. The lower one is 2. So remember, a sandwich, right, is made up of two pieces of bread. So you imagine that the top part is the top bread. The bottom one is the bottom bread. So the area is sandwiched in between, whatever you put in the middle for your sandwich. Okay, so now when you combine the two, so you will have integrated from A to B, 1 minus 2. Alright? Okay, so if you are using the x-axis as a boundary, you integrate with respect to dx. If you integrate with respect to the y-axis, right? Sorry, this one here is y. Then you're going to use dy. Okay, so what do I mean? If I have a question like this, okay, like this and like this, right? And you wanted to find this one here. So you are thinking of sandwiching this and this. If you had imagine it, right, this will have been your boundary. Okay, so this is your x-axis. Then you use dx. But if you have a question like this, all right, where you can imagine that you could have actually used y as your boundary. Okay, this way, it's like flowing down this way. All right, so y is actually the axis that you're going to use. Then you use dy. All right. Okay, so now you can try to find a case where we are making use of the sandwich method. All right. So first of all, before we can do the sandwich method, which we are going to do here, all right, we are going to find k and h first. So how do we find k and h? This is k and this is h. So this is question 7. All right. So they have given you the equation y equals to kx minus x squared, and they have given you a clue. P is 2, 0. So when x is 2, y is 0. So 2k equals to 4, so k equals to 2. So now we know that this is actually going to be 2. All right, so our equation now, I just write at the top, 2x minus x squared, just for you to see. Now, once we know that, then of course we can find the k value as well, the h value as well, right? So when h is the y, so we have it as 2 times 3 minus 3 squared. So we'll be able to get it as negative 3. All right, so q is going to be 3, negative 3. All right, can you remember that? All right, so now going back to this question here, so we already know this is 2 and this is negative 3. So using the sandwich method, we don't have to worry about minusing anything, right? So we just need to know that we have the curve and the line. So I'm just going to draw again in a different color. So the top part, which is green, all right, will be this one here. So this is the top, which we're going to call it as equation 1. Then we will have this one here, which is the bottom, okay, and we'll call it as equation 2. Now, I think you should be able to recognize that we have an issue here because we don't have the equation, all right? And because we don't have the equation, we have to come up with the equation ourselves. So this is where it might be a bit more troublesome because you need to know the equation. So no problem, we can actually find, since this one here is triangle, right? Okay, so we can have here is 3 units, here is 3 units. So the gradient is actually rise over run in a downward way. So it will be negative 1. Since the line passes through the origin, there is no y-intercept. So it's just going to be the equation y equals to negative x. So not too bad now. You can still come up with the equation on your own. So this will be your 2. Alright, so remember, we are going to integrate between the, this is the shaded part, right? So the very first x value would be 0, okay? And the second x value right at the end here, this is the one, 3. Okay, so we're going to integrate between 0 and 3 because my gray color part, the shaded area that I want, extends from 0 for x all the way until 3 for x. All right, so I'm going to use x as my boundary. So this is the value. So the entire thing here between 0 and 3. So remember, equation 1 comes first. So 2x minus x squared minus away equation 2, which is this one here. So we have this one. Okay, so simplifying it, we'll have it as minus is plus, right? So we have 3x minus x squared dx. So this will be our area that we want. Alright, so this one here, remember, no need to minus, so it's straight away what you get. Alright, so in this case here, we're going to have 3x squared over 2 minus x cubed over 3, integrate as per normal. Putting in the values, we have 3 squared over 2 minus 3 cubed over 3 minus away 0. I don't bother to put in, everything will be 0, okay? And then when you calculate this one here, you will be able to get it as 4.5. Okay, right, it's 4.5, it doesn't matter. For some strange reason, a lot of our area end up as 4.5. It's not always, it happened to be, alright? So in this case here, that is how we get the area, okay, using the sandwich method. So this is the curve minus the line, kind of speaking, alright? So as I said, can be line first, but it happens to be that for this one here, the top part is actually a curve. Alright, now, of course, some of you will be wondering, is there another method? Yes, we can also do the push method, which means that we don't have to worry about the finding the equation of the line. All right, just now we had to find the equation of the line, right? So now if you're going to do the push method, you will realize that I am going to push my curve up because currently my curve, some parts are in the positive, some parts in the negative, right? So I'm going to push the curve such that it becomes this way here and it's resting on the x-axis. So this will be the shaded area that I want. Then this one, I will be using the minusing method, minus the triangle method. All right, so let's have a look here again. So why I push by 3 is because remember our h is negative 3, right? So you are actually going to push the curve up by 3 units. So remember, this was the equation that we have, right? So I'm going to put a plus 3 because I'm pushing up the curve into the entire positive area. So it has to go up. So it's plus 3. So this is going to be my new equation, 2x minus x squared plus 3. All right. So I am going to integrate also the same thing. This is also going to be from 0 to 3. So 0 to 3, area under the curve. Now, why I write area under the curve is because later on, the area that I want, I have to minus away the triangle, which is this one here. All right. So I'm going to integrate with respect to this. Okay. And I'll be able to get it as 2x squared over 2, which I can cancel off. X cubed over 3 plus 3x, 0 and 3. All right. So replacing will have 3 squared minus 3 cubed over 3 plus 3 times 3. And again, you will just minus away 0. And I'll be able to get this as 9 square units. Now, I still have to minus away this part here. Okay, this one here. So remember, earlier on, we already knew that this is 3 units and this is 3 units, right? So this triangle area is half times 3 times 3, which will give me 4.5. All right, so in the end, my shaded area will be 9 minus 4.5, and you will also get it as 4.5 square units. Alright, so I have given you a variety of methods for area under the curve bounded by a line. Okay, so you can have the push method, you can have the sandwich method, you can also have the minusing method, like for instance, you minus away the triangle or the rectangle or the trapezium. Whichever you like, it will work. But see, because sometimes you can have a mixture of methods, or you can just stick to one, which is the sandwich method. So the sandwich method is actually quite useful. The only problem is, like what I mentioned earlier on, your sandwich method, you will have to have two equations. All right, so the key word here is that you must have two equations. So let me highlight two equations. All right, so no matter what, you will have one linear and one non-linear. Then you can do the sandwich part, right? So like for instance, maybe you have the top sandwiched by the bottom, or you may have a case like this where the line comes first and then the curve comes later on. All right, so hopefully this has been useful